I've come up with an idea for a one-of-a-kind camping stove with features on it that I've never seen done before. So today we're going to be building it and we will be testing it out as well. So stick around. I want something portable that fits onto or into any backpack. It can burn anything woody that you would be able to find on the ground. I want it to be self-feeding. I want it to be able to boil water and cook food. And I also want to achieve the holy grail of rocket stoves. I'd like to see if we can get the temperatures high enough to have that secondary burn. My second version looked like this. It did address a lot of the issues that we had with the first model, but after doing a little bit more research, I might have a problem with blowback because exhaust can also move up the chute or up the hopper fairly easily. So I decided to go back to a more monolithic approach. So basically we have everything without any fluff. So in my newest design, what you're seeing here is the stove in its base form. And when we want to use it, it transforms. I have all of the parts neatly stored inside of it as well. And when it's in stove mode, it has a big hopper. It has the classic rocket stove shape as well, with the air intake at the front. The flame moves horizontally first, and then it should go up the chimney. The biggest issue with the small rocket stove is the size, and that means that we have less heat. Less heat equals more smoke, lower airspeed, more impact from wind, and overall poor performance with moist sticks and branches. So what I did was I designed a space for insulation. And the great thing about the insulation is that not only do we retain heat better, it also dramatically reduces the external temperature, making it also safer to use. Last video we used stainless steel to make all of our parts, but I'm getting a little bit low on stainless steel and it is pretty expensive to use for prototypes. So I have some cold rolled mild steel and the thickness ends up being exactly the same as the stainless steel, 395 thousandths of an inch or exactly 1 millimeter in thickness. Last time I was using the metal fab, I was using this nozzle, which is called the gas saver nozzle. I was calling it the air saver nozzle. And it has that little ceramic tip which rides along the surface of the material. When it does that, it does tend to scratch the material up, which I don't really care about. But the other issue with it is with this particular type of material and the intricate parts that I'm trying to cut, what can happen is that little ceramic tip, as this part gets some heat into it and starts to warp, it can get caught up on some of those areas because it's riding right along that surface, and then the ceramic tip can break. So that's what happened when I was trying to cut this, and you can see I was having good success up until this point here. Now I was doing something I should not have been doing. I did not have a clamp along this edge because I was trying to get the most yield possible, and that's part of the reason for that warpage and part of the reason for the break. So to avoid that, for this material, this thickness, I'm going to be switching back to the standard nozzle, 2 millimeter orifice nozzle, and this one works really well. It rides just above the surface of the material. So let's get this one loaded in and then we'll make some cuts. So I do have clamps on both ends this time. I was having a good time welding, but unfortunately I had to stop because I could not just close this in without putting in the insulation. So I have the insulation here. This is ceramic wool or ceramic fiber insulation. This is extremely high temperature insulation, 2000 degrees Fahrenheit, which is 1093 degrees Celsius. So I'm gonna get this unpacked, but before I do, I have a little bit of safety equipment because you're not supposed to breathe this stuff in, and I don't really want it getting into my fingers as well. All right, so the sides are just fitted there tightly now, where they're not welded on. So I can remove them, and they're a tight fit. There we go. And this is just from Amazon, this stuff. So pretty inexpensive. Obviously it wasn't very big, but it was big enough, plenty big enough to do the job that I needed to do. Well, I did not have success with the hopper door. It was going pretty well up to the point where I welded it to the hopper itself. And you can see I was able to salvage the hopper, not the door, not the hinge. So I have redesigned both of those to be much better. But I've also redesigned the hopper, and the reason for that is because it was a little bit tight. This is what I have set up for the hinge, and actually it's more stable than it looks. So I've got magnets on each side that raises the hinge up above the knuckle. That way I have a flat face here. So hopefully we can get this cut, and it makes assembly much easier. This is everything. It's all built into this one design, even the door on the top there. And I don't have a better solution than this right now, but eventually I'll replace the screws with something else. So I have 4 screws, and we also have this piece that comes out, and that goes right in the bottom like that. And I also have a tray or a drawer for the ashes to collect as well. Like that. And I don't have any of the legs sorted out yet because I didn't want to go too far with the design before I actually test it. All right, I think we are ready. So you can see the size difference between the new version and what I had built last time. So I've already collected a bunch of sticks. Unfortunately, again, it just finished raining, so these are really wet. And then I have some wood from my firewood stack. Again, some of these are a little bit wet. And then I have some dry wood from my shop, which is just cherry wood. And that's what we're going to use to get the fire started. So here's where we're at. Not really that good. I think I don't have enough air intake slots to make this work properly. I don't think there's enough air coming in, so I might add another layer on top. The other thing is I removed this grate because what was happening was all the coals were building up at the bottom and blocking the air from coming in. So not really ideal either. So maybe I should add some holes at the front too, a couple holes at the front here on that side, and then another layer up above. Check this out. It works. It's warm, but it works. More along the front on each side as well. So let's give this another go. I think this is going to work much better. It definitely seemed really starved for oxygen. As soon as I put the newspaper in there, it hasn't ignited. It sealed off this quite a bit better, and now it's doing exactly what it's supposed to do. So this design might need a sealed door. If I were to guess why the chimney is not working correctly, it's because the volume of gases that it can hold at any moment is far too small. I think I need to experiment with creating a much simpler and completely open chimney without insulation and a wider mouth for entry into that chimney as well. These volatiles, which we were seeing collect at the top of the hopper, should be moving up the chimney instead and helping us to get that secondary burn. I think the concept is good. I think the size is pretty good. The build quality is really good, but the function is not quite right. There's still more work to get that to work properly. So let me know what you think. If you have any ideas of how to get this working correctly. I think there's still lots of potential here. And like the last video, there's a lot to learn from building something like this and testing it out as well. So we can just continue to build on these ideas, and eventually we'll get something that works really well. Bringing these type of ideas to life is only possible for me using the Xtool Metal Fab, both in CNC mode and then also in the welding mode as well. I'm even starting to get the hang of welding freehand on 1mm thick material, though I think it might be possible to build a guide to get even better looking results. The fillet welds always look amazing with this laser welder though. So if you're interested in taking a closer look at this machine, I'll leave a link down there below where you can find it. And Xtool has provided a discount code down there below for you as well. I hope you enjoyed the video. Thanks to my patrons for helping to support the channel. Take care, and I hope to see you on the next one. So this cherry here does not seem to want to light very well. So I tried switching over to maple, and we have a really good fire going. Look at this thing. Now the problem is still, when I close this up, it gets really, really smoky. So I don't think it's actually that far off from working correctly, but this hopper style is not going to work. I think it needs to feed in on an angle right into the burn zone, and air needs to come up from below. But my success might have a little bit to do with the wood I was using too.